Welcome back. Now let's talk about some of the things that were discussed in that video. So the basic logic behind experiments are that we are looking for causation. As scientists, we want to understand what causes what. So some of your studies, you might have said for your hypothesis that you wanted to understand if a child temperament causes an attachment, or maybe a parenting style causes a specific attachment. Maybe if having a certain SES causes a certain kind of teacher quality or a student achievement. So maybe teacher quality causes a certain level of student achievement. So with our study, it was a survey study. We couldn't actually look at cause, but with an experiment, if you did an experiment, you could look at cause. So let's use that teacher quality and student achievement example. So one thing, the basic logic is time precedence. If A is consistently followed by B and the opposite isn't true, we generally conclude that A causes B and they're not just related to one another. So if you have high quality teachers and they're always having high quality students, but high quality students don't somehow create high quality teachers, then you can generally conclude that the high quality teaching led to the high quality student achievement. So high quality teachers leads to high student achievement, but high student achievement won't create the good teaching. So that's what time precedence means. A is followed by B, or A causes B. Another example is, let's say if you scratched your arm, you just took your fingernail and you just scratched on your arm for a little bit, it would turn red. Your arm would get a little red, but if you look at your arm and it's red just already, and that doesn't cause you to then go scratch your arm. So you scratch it first, that's A, and then B is that cause. Alright, so hopefully that's clear. So some types of causation is like these examples that I've been giving, unidirectional causation. So some experiments or some psychologists think that heat leads to an increase of aggression, so causes that. Bidirectional causation, something like guilt can cause anxiety, but anxiety can also cause guilt. So that's bidirectional. They can cause it both ways. So, and there's also this non-causal covariation, and that's basically the correlations that we've been talking about through most of the class. So the example that I've given before is the marriage rate declining during the Great Depression, as well as an increase in suicide. So those are two related variables, but they were actually caused by the economic depression. All right, so when we're investigating cause, when we're trying to figure out what a cause is, we need to have control over our variables or over those phenomena of interest. So if we want to see if teacher quality leads to good student achievement, well, we have to have control over our independent variable of teacher quality. So we'd have to have teachers that are really low quality, teachers that are medium quality, and teachers that are high quality. Test all of those, and if it really is the cause that teacher quality leads to good student achievement, then we should see the higher quality teachers lead to higher student achievement. So we need control over those variables somehow. So the independent variable is the one that's manipulated independently of its natural sources. So it's also called the treatment, the manipulation, the experimental variable. It's the independent variable, or IV. It's the one that you manipulate or change. So in our example, it is the teacher quality. We pick only 5 teachers that are really great quality teachers, 5 teachers that are very clearly medium goodness teachers, and then 5 teachers that are really poor teachers. So that would be how we could control that independent variable. All right, the dependent variable is the one at the end of the study, basically, the one that's affected by or dependent on the independent variable. It's kind of like the final measurement variable. Another name for it is the DV. So the dependent variable in our example would be that student achievement. So we're manipulating the IV with different levels of teacher quality, then we're measuring that DV, the dependent variable of student achievement. So only in experimentals methods is there a clear specification of independent and dependent variables. You can predict things in correlational studies, but obviously it's not a cause. But you can have a predictor variable, right, and a criterion variable. So that's kind of like the independent and dependent variable in a correlational study. But yeah, I don't want you to get confused. You can go and review criterion and predictor variables. We've already talked about those. So, and also with experiments are the only kind of place where you can plausibly specify causal relations. So if you have a correlational study like we had of teacher quality and student achievement, you might see a positive correlation that as there is higher teacher quality, there is also a relationship with higher student achievement. But that doesn't necessarily mean that that correlation is showing a cause between teacher quality and student achievement. It might be that both of those variables were caused by having, I don't know, maybe a good quality school climate. So you have a good quality school climate, maybe you have good quality administrators that hire high quality teachers, but that school climate encourages students to perform better, and so that's why they have higher student achievement. So with correlation, we can't tell that that's the cause, right? So we would have to have an experiment to see if teacher quality really is the cause. The correlation can suggest that it is, and then we would do an experiment to make sure. But yeah, we can only tell cause from experiments. All right, so a problem arises because there are confounding variables. There are things that vary along with the independent variable, other things in the environment, and it makes it hard to determine what is affecting the dependent variable. So we have our teacher quality that we're manipulating, our high quality teachers, medium quality teachers, low quality teachers, but a confounding variable might be that school climate, right? So that school climate might change. So maybe if you have a medium teacher and high quality, or a medium quality teacher and a good school environment, school climate, you might still have high student achievement. So it might confound the relationship there. So with that, you really need to work on your internal validity. So back to talking about validity, we need reliability. We need a measure to be measuring consistently over and over again. We need our experiment to be consistent, but we also need it to be valid. So internal validity are the things inside the experiment getting at the thing we want to. So the inside of the experiment, you could think of internal validity as. So can the results of our experiment plausibly be attributed to the effect of the independent variable? So if we do a controlled experiment where let's say we do this experiment in the schools. So we have high quality teachers, medium quality teachers, low quality teachers. Then we measure the student achievement and we see that there's a relationship there. The problem is that we have that confounding variable of school climate. That might have been part of the cause as well. So one way that we can have higher internal validity is by taking this experiment to a lab and testing students and teachers outside of that school context. So that school climate doesn't exist anymore. And so in a lab, we have we have a high quality teacher teach a lesson, a medium quality teacher teach a lesson, and a low quality teacher teach a lesson. In the lab, so there's not really any school climate. It's not even the student's teacher, so there's no relationship there. That would be a better way to get at more internal validity, to show that yes, it has to have been the teacher quality that led to an increase on student achievement. So that's what internal validity is about making sure that the IV, that variable, the independent variable, was the cause of the change. And that's the only way to draw those causal relations from the data. You want the highest internal validity you can get. All right, so let's talk now a little bit about types of groups for study. All right, the first example of an experiment that I want to share is the post-test only control group. So that one's pretty simple. It's a post-test only. So if you look at these symbols here, the X is there in place of a treatment. That's what that means. And the O's are a measure on the dependent variable. So if we take our teacher quality and student achievement example, this would be a one experimental group on teachers. So maybe so we've got a group of high quality teachers, and then down here a group of control teachers, or maybe just the average teachers of the school, or even our control group could be the low quality teachers. But let's say this is our group of high quality teachers versus average teachers at the school, and then we don't do any and then all we do is we give the treatment high quality teachers versus the average teachers, and we randomly assign students into those classes and whatnot. And then so we randomly assign half the students to the high quality teachers, we randomly assign half the students to the average teachers. Then after they've gone through a week's worth of lessons, we give them a unit test. That's our dependent measure of student achievement, although there's a lot of ways to measure student achievement. And then we find which group was better. Was the high quality teachers better? Was the low quality teachers better? And this is where you would look for the pattern in your results. You would expect to see a higher mean on the test scores for this group than for this group. You would also check that with like a t-test to see if it's statistically significant, but also be looking for not only that statistical significance, but also how large that effect is, the effect size, the mean difference. All right, the next example is a pre-test, post-test control group experiment. And so the benefit of a pre-test is that we can tell if these two groups are the same before we do the test. So again, we're randomly assigning half the students to the high-quality teachers, and we're randomly assigning half the students to the average teachers. So the benefit of a pre-test is we can check to make sure that the students in here with our random assignment are really about the same as the students in here. So we test them on a unit test, and we see they get about the same score. That would be what we would want to see. If for some reason we had a lot more higher achieving students in the control group, that would be okay with doing a pre-test post-test, because we should see no change between this point and this point in their mean, or very little change. But this group, even if it starts out lower, the experimental group, even if it starts out lower, we should see it rise. So that's what we're expecting. So even if still in the control group, even if somehow with our random assignment we got more of the high student achievers in the control group, and so their mean is still higher than the experimental group's mean, as long as the experimental group's mean is going up and the control group's mean is staying the same, that suggests that our experiment worked, that the high quality teachers are improving student achievement. So that's what's good about the pre-post-test group experiment. So the pre-test makes it possible to check for that equivalency before a treatment. When you're randomly assigning, it's less necessary to check for that equivalency, but you'll always find situations, just on occasion, that the groups are not completely equivalent. That's the purpose of the random assignment, is to make the groups as equivalent as possible on all sorts of confounding variables. So that's how you take some of those variables out, but it's not perfect all the time. And the larger your groups are, the better chance that you have of making sure those differences are randomly distributed between those groups. So let's continue. So we've used the example of a teacher quality experiment. Now here's another example. So let's say you want to test a drug for anxiety. So you take 60 people and you put them into two groups. One randomly assigned group of average volunteers has a sugar pill, and the other group of randomly assigned people has a medicine. Let's say you're trying to cure high blood pressure. So you have 60 people, 30 at random are in your sugar pill group, 30 at random are in your real medicine group. So, oh, I'm sorry, this is about how anxious they are. So your pill is supposed to make them less anxious. So after taking the pills for 1 month, you give each person, all 60, a clinical interview, that would be your dependent measure, and determine how anxious they are. So what type of experiment is that? I think we talked about this one the other day in class. This would be a post-test only, because there is a control group and there is an experimental group, so it is an experiment, but there is only a post-test. There is not a pre-test. Compare that to this example. You want to test that new drug to reduce anxiety. You take 2 people, put them in 2 different groups. One randomly assigned group of volunteers has the sugar pill, the other has your medicine. Alright, so when you bring them in to describe this study and give them the pills, before you even give them the pills, you give everybody a clinical interview. So that would be your pre-test. To determine how anxious they are, they're sent home to take the pills. After taking the pills for a month, you give each one another clinical interview to see how much their anxiety changed. So that would be a pre-post-test experiment, because you tested them first, then they did the treatment or the sugar pill, so they were either in the experimental group or the control group, and then you did a post-test. So which of those two do you think is better and why? Maybe pause the video for a second and think about it. Also think about in what situations might it be better to use a pre-test, post-test experiment versus a post-test only experiment. So pause the video for a minute and think about those things. Alright, I wanted to give the example. I tried to go over this really quickly in class the other day, but I want to spend just a little more time on it right now. So this is an example of a purpose intervention that we ran. We had a couple different conditions. So condition A and B were 2 different classes that had 2 different types of the intervention. One was focused more on values clarification, the other was focused a little more on goals. And then we also had a control group for those groups. So that was this D group. So A and B had one control group that was just average. They did some memory, very similar to our mnemonics experiment in class. They did just some memory tasks and study skills workshops rather than anything to increase purpose. And we also had an AP class, or a couple AP classes. So we randomly assigned some classrooms to the A group, randomly assigned some classrooms to the B group, randomly assigned some AP classes to a treatment group, and randomly assigned some AP classes to a control group. So we had 5 total groups, 3 treatment groups and 2 different control groups, one of the general classes and one of the AP classes. So we had 3 treatment conditions, 2 control groups. We had a pre-test, a post-test, and we also had a lag a few weeks after that post-test to see if any effects were remaining or if those effects were dying off. So did we need that pre-test? We have a post-test and a lag, so that would let us see some of the control groups. They would presumably be the same across these 2 points, right? So we could have designed it this way. What are the benefits and risks of a post-test only design? Now we'll talk about that in class when I come back in a few days, but think about that for now. So this is the results that we got from this experiment. This is if we had only looked at the post-test. So we've got groups A and B. So that is the general classes, 2 treatment conditions. Then this D, all interventions condition, that is the AP class or classes that had the experimental condition. So all these top 3 had the treatment. These bottom 2 here had were in the control. They had just the study skills. So if we look at this, the biggest mean is this AP control group. So why is that there? Well, it looks like maybe people who were in a control group were higher on purpose. So if we got this result, we might think that our experiment failed because the highest group was a control group that got no purpose intervention. But when we look at the pretest, we see that that score didn't really change. The scores that changed the most were actually the AP students who had all the interventions all crammed into one curriculum. And so you see they started with a 5.29, they ended with a 5.46 versus the other groups. The other treatment groups didn't move very much or even went down a little bit. So we learned that having all the interventions crammed together rather than separating them like we did with these two classes worked better that way because we were looking at the pattern of the data as well as the numbers and the statistical significance of that change. So, so think about what problems can a pretest cause. So pause the video for a second and think about that. So some things that can be a problem are that it's more expensive and time consuming. You can change a participant with a pretest. You can sensitize them so the treatment works better. So we're doing a purpose survey as a pretest. That might get them started thinking about their purpose. You might get more attrition. People are bored of your material and your study, so they stop doing it. So a solution to some of these problems of the pretest is to do a Solomon 4-group design. So basically we have up here a post-test only experiment, and you can see down here a pre-post-test experiment. So if you put all 4 of those together, you get 4 groups, 2 treatment groups right there and right here, and 2 control groups right here and right here. And you are controlling for these variables because you have 2 groups without a pretest and 2 groups with a pretest. So you can compare if the pretest had any effect. You can see, did the pretest have an effect on the control group by comparing this point, and this point of data? And you can do the same thing to compare if the pretest had any effect on the treatment group. So check this point, and this point. You would think if the treatment worked, the means would be nearly the same between here and here. But obviously it might not be the same if you have groups that aren't equivalent to begin with. Just for some reason, just like the AP class, it would be possible to have people that were just better on your measure in this group. But this is a great way to get around some of those problems of the pretest, because you have some people without the pretest but still have the treatment and still have a control group, and some people with a treatment or with a pretest and the same thing. So it allows for a lot of more comparisons that way. So here's just another way to think about it or look at it. No pretest, no treatment, post-test. No pretest, treatment, post-test. It's just the same diagram, just put up in words, if it helps you at all. So it lets you see if there is a pretest effect. Perhaps the pretest did make people increase on purpose more because they started thinking about it in the pretest. Your pretest can change people's behaviors in other ways. You could create a confound from your pretest. So testing the pretest effect can really help. But with the Solomon 4-group design, it does require more people because you now have 4 groups. It's going to be a little more expensive, but it is a really great design to use. And we will talk about some other groups and some other designs when I am back on Wednesday. Hopefully we'll have an in-person class, and I will see you then. And on the PDF, there might be a few example experiments that you can go through and try and see if it is an experiment, which type of experiment. Is it Solomon 4-group? Is it pretest post-test? Is it pretest only, or is it post-test only? Go through and check those really quickly.